The topic of the presentation is text encryption with Advance Encryption standard for near-field communication NFC using Huffman Compression. The presenters are Adeniji Odi, Olaniyan Elias Akinola, Ademola Oluwasola, Olamide Afolabi of the Department of Computer Science. The agenda of the presentation are as follows: introduction, problem statements, review on literatures, methodology, results, and discussion conclusion. Introduction. The combination of Huffman code with some cryptographic algorithms, such as symmetric encryption algorithm, will guarantee multi-level security. This poses a lot of challenges in order to protect the original word list from intrusion without damaging the existing bits. The focus of this study is to mitigate against intrusion in the level of communication transaction between the card and the reader. Privacy and authentication are the major concern in reading frequency identification system. The protocol implementation in transfer of ownership in mobile application normally consider handheld components from reader to back-end server. So to secure and provide counterfeit measures, transaction of RFID system, where tags with limited resources are very important. There is need to provide an ownership transfer which has been developed to improve the maintenance of specific application, and these applications are being applied in the area of ubiquitous computing, logistic management, and traceability. Cryptanalysis has been also implemented in protocols such as EPC C1G2 standard, thereby analyzing the level of security. The focus of the algorithm when it was tested is to reduce collusion and use time division multiplexing. The implication of this is majorly to correct reverse protocol error correction. So encryption is a technology for protecting sensitive data. Most algorithms used in encryption combine both publics. Basically, encryption usually hides sensitive data of users, which are used for information retrieval. So data encryption standard DES can encrypt and decrypt using shared secret key in form of block ciphers. So AES is fast and flexible. To crack cipher during operation requires the use of different multiple keys. Problem statement. Huffman code can access both code word lists with encoded bits in order to decode the message. In this way, improper error correction algorithm with encoded bits can be damaged, resulting to a total loss of information. So what we are trying to find out or to provide solution to in this study is how we can mitigate the loss of information. However, the code list and the code bits sent to the receiver requires some certain high level of transmission time. So there are need to provide countermeasures techniques to secure and fix the damaged encoded bits. In these studies, we review some papers that are related to the topic of presentation, and paper 1 and 2 discusses the limited computational and energy resources due to low complexity and high compression efficiency. Symmetric key block cipher algorithm was developed, describing the analysis of several algorithms. Huffman coding was presented in that study, and it was applied to different data such as video, image, text, and other formats. The observation is that characters with shorter string of bits are used for less common source symbol. In another related study, provided an efficient compression method which can map individual source symbol to unique string. The significant role of encryption algorithms are numerous and essential in information security as adopted in literature 7 in comparative study of symmetric cryptography mechanism. Another paper was reviewed, thereby stating the level of attacks that have been predefined and to also provide the various level of characteristics in the nature of the attack as it was proposed in paper 8. A secure text encryption with near field communication using Huffman Compression was also proposed in paper 9. Character proximity for RFID smart certificate system, which is used to curb forgery menace, was provided in paper 13. Materials and methods. The design of this study are in 4 modules. 1. Module 1 is Information System Module ISM, the Card Interactor Module CIM, the Middleware Module MMM, and the ISM is the center of the system and consists of 3 modules, which are the core, infrastructure, and the web API. The core is the center of the system. It implements the entity, the business rules, and makes sure data is securely accessed. Infrastructure layer handles external concern on the database, calling an external endpoint, sending email. The card interactor module CIM is the second part of the design architecture. Basically, the CIM is the hardware and the CIM is the API communication with the card through the interface provided through dependency injection. Interactors middleware is the third stage, which consists of reciprocity, logic, security, and the interface. The repository is a storage mechanism that hosts both structured and unstructured information. During the simulation, the logic layer ensures that the information created or updated are in conformity with the set of canonical rules. The logical layer ensures integrity. Below is the logical layer is the security, which ensures that information of the system are properly secure from an unauthorized action. So the simulation was implemented using reader ICAI 1311, which supported both Bluetooth and USB 2.0 connection. The near field communication card is the Wi-Fi. Below diagram shows the algorithms for implementation. The first stage is to check the AES mode. When that is done, it configures the unique character register. It passes it to write the payload to the buffer. But if this is achieved, it passes this information to the AES mode. But if not, it goes back to the configuration unique character register to configure the set of AES mode again. But if that is achieved, that will be passed to AES mode, which generates unique character mode. And after that, keys are generated to the unique character mode and it provides an output result. These results are written back to the buffer and the buffer will send an interrupt of unique character for registration, and that will terminate the process. This diagram shows the development of the simulation, which we are coded with C# and with other tools with the card. This first interface shows the starting pooling. Here the card was not detected, but in this other diagram, in this other interface, we have the interactor windows card being detected, which shows the initialization of the ACR 1311 PICC reader and the card status, which are represented in hexadecimal, and it shows us the active protocol T equals to 1 and the card type MiFi standard 1K. After the simulation, since our investigation is particularly showing the importance of entropy, the password predicts how a given password will be cracked through a bootstrap or guessing. So we have about 4 equations here that depict works. The above equation 2, 3, and 4 shows how difficult the password will be guessed, and it is important that at least one character is chosen from each of these three sets. There are 6 character key is further separated and hashed before a better security is implemented. So the higher the entropy of the initial text, the more accommodating the output size to change in the value of n. There is also a direct correlation between the value of n and the output size as seen in figure below. Here, when n equals to 100, these data were captured and you can see the output size and the number of unique character. Another experiment was performed when n equals to 200. It also depicts the pattern in which the number of unique. So the performance evaluation to determine the time required for encryption was conducted in another related experiment. Here, when n equals to 50, it was gathered that the CBC and the ECB at AES running mode shows that unique character equals to 2 and the CBC optimal is 0.13 microseconds and ECB at optimality is 0.12 microseconds, and the symbol by symbol restriction drops with a known input distribution. But when n equals to 100 with a unique character of 2, the running mode of CBC was 0.13 microseconds at optimal and the ECB was 0.05 microseconds. Also, a single code may be insufficient. In this case, all the single code may be insufficient for optimality. And the last experiment that was conducted was when n equals to 200 and the unique character was 0.05 in AES running mode and the CBC at optimal was 0.23 microseconds and ECB at optimal was 0.23 microseconds. The important performance determinant is the time required for encryption. AES was implemented in both ECB and CBC cipher mode to compare performance as shown below. The symbol by symbol cipher mode can determine the correlation running time, thereby protecting the level of communication transaction between the card and the reader. Conclusion: redundancy and pattern of stored content with less space is assured in the development of this study. Unique character has different location on the tree. The character may not represent the same numbers of bit length. The developed module in this research used AES techniques to secure and fix the unique number of characters at different locations on the tree, with n denoted in the explanation. So the use of application protocol APDU as a medium of communication between a smart reader and a smart card contains mandatory byte acknowledgement. The research was conducted at the Department of Computer Science, University of Ibadan, Nigeria, and the author thanks the department for their support in this research work. The references can be found